Assalamualaikum and hi to Sir Erman and my fellow friends. My name is Iza. So today, I would like to present you the introduction for our data communication and networking project. First of all, I would like to introduce you to our group member, which is Nurul Ashikil, Nur Iza Fakihah, Bishan Nubarkis, Muhammad Zulkarnain, and Muhammad Amirul Asraf. Okay, so University Technical Malaysia Melaka, which is UTM, is one of the top technical university in Malaysia. UTM focus on the technical fields, especially engineering and computer science. There are 10 faculties at UTM, but 3 of the engineering faculties, which are FPDT, FEKE, and FTKMP, are located outside of UTM's main campus. Not so far from the main campus, as a university, UTM need a network design to connect all the faculties and facilities together with the internet. Our network design will be focusing on the main campus, which include the faculties, except 3 that I mentioned above, and other faculties such as registration office, sports center, library, and others.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Asraf Mustafa from Group A, and I will be presenting the network design that we are proposing for the UTM local area network. So the topology that we are proposing is the star topology. So as you can see in this diagram here, this icon here is is symbolized a router. So each of the sub network will have their own router, and all of this router will be directly connected to the main router in the computer center. And then from this main router, it will be connected to the wide area network by going through a firewall. So in this design, the main reason that we are proposing this star topology is because it has a high fault tolerance. So since every of the subnetwork have their own dedicated connection to the main router, so let's say if there is a technical failure or network issues in the FTMK, only FTMK facility will be affected, while other subnetwork will not be affected since they have their own network, they have their own connection to the main router. So this characteristic also help us to easily pinpoint the root of the trouble. So let's say that FTMK has technical issue, of course the problem relies on FTMK since others have no issue. And also since the connection is centralized to a single router, it also help us in managing the networks, because let's in like shown in this diagram here. So we only need one firewall layer here because all the connection will go through the main router, and then only main router will go through the firewall. So we don't have to add firewall. So the other router doesn't have to have their own firewall. Only one firewall from which we between the centralized router and the wide area network. So in this sense, it increases the manageability of the network because we can simply manage it from the centralized router. And then as for the communication media, we choose the fiber optic. So mainly for its transmit distance. So UTM is quite large facility. So if we use some other cable like UTP or STP, so we're gonna need a repeater in every 100 meters. So it will be quite inconvenience. And also cable like UTP has very low resistance and tolerance, so it is not suitable for outdoor cabling. That's why we choosing fiber optic. So besides its durability and the distance, fiber optic has also far better bandwidth compared to other cable, which is going to be needed in UTM since UTM network will be used by thousands of students and staff. So we need the high bandwidth that are offered by the fiber optic. So as for network device, as mentioned here, we have routers and also a firewall here. So some router might support firewall built in, but we depict it as separately in the diagram to emphasize the existence of the firewall, and also to emphasize that the other router doesn't necessarily have to have firewall support. Only the centralizer need it. So and then I think that's enough from me. Thank you.
Assalamualaikum and a very good day. My name is Michelle Balkis binti Syaful Azmi, and I'm presenting about the computer center from the Explore to Center 4. So the computer center at UTM consists of multiple servers for UTM systems and the PPPK department offices office. The facility consists of 3 floors, and to improve network efficiency, we have proposed the following network design. So the main network will have an extended star topology. This means that all network connections will be centralized into a single router, which acts as the gateway connecting to the local area network and the wide area network. All server machines will be directly connected to this main router to ensure optimal network performance since they will be used by multiple users simultaneously. So this setup also allows for isolation problems. In any case, if any server requires maintenance or goes offline due to technical issues, it will minimize the impact on other servers. 2 PCs dedicated as control panels for the router will be deployed in the server room, directly connected to the router. This will make sure that the network management is easier through a user interface on these PCs. Each floor will have a dedicated switch directly connected to the main router. In a star topology, this ensures that any technical issues on one floor will not affect the other floors as long as the main router is functioning. Additionally, a wireless access point will be directly connected to the main router as a backup option. If any of the switches fail, staff can still connect to the network using the wireless access point. The access point will be placed in the middle of the facility to ensure stable coverage throughout the building. Here on the second floor, each room will have a hub to facilitate easier cable management. The connection between devices on the second floor and the second floor switch will generally follow a bus topology. For the first floor here will serve as a customer service area and a workstation for technicians and support staff. The customer service area will have tools like telephones, computers, tablets, and databases for customer interactions and support. The workstation for technicians and support staff will focus more on providing technical support to internal users such as employees to resolve IT-related problems and minimizing downtime. That's all from me. Thank you.
So this is the part where we do the subnetting for the 10 department. As mentioned in the blog, we are going to use IP address class A, which is 10.1.0.0, and we utilize it as the main network for subnetting. There's a few reasons why we use this IP. It is because this IP located in the category of class A, which means there are so many hosts can we put it in. So the main network address serves as a reference point for organizing and managing the IP address space. It allows for the allocation of subnet to different parts of the network, such as building or department. While 10.1.0.0 was chosen here, other value option could have been used, like 172.116.0.0. The specific choice depends on factors such as network size, organizational preferences, and compatibility with existing infrastructure. By selecting a larger address space, there is more flexibility in allocating subnets with varying number of hosts. In this case, the faculty FTMK require 500 hosts, and the chancellery office needs 450 hosts. Having a larger address range ensures that there are enough available IP address to accommodate the required number of hosts for each building without having a problem running out of the addresses. Moreover, using a larger addresses space allows for future growth and scalability, as it provides rooms for allocating more subnets and hosts as needed. Essentially, the selection of the main network is a design decision based on the specific needs and consideration of the network implementation.
Now for the calculation, we arrange from the number of hosts that larger to the number of hosts that smaller, so that it's much easier to calculate the address for each host and faculty. The first one is FTMK with 500 hosts, and the quantity of hosts is with you is to the power of 9, means that 9 bits borrowed, and the to the power of 9 is 512. So it's much bigger than 500. Then this is the network address and the IP address range and the broadcast address. The network address is 10.1.0.0, and the IP address range is 510 or 510 IP address from 0.1.0.1 until from 10.1.0.1 until 10.1.1 and 254. And the broadcast address is 10.1.1 and .255. And for the cancellation of this, we need 450 hosts. Then and the bit borrow is 92 because it is much bigger than 450. And this is the network address, IP address range, and broadcast address. The network address is 10.1.2.0, and the IP address range with 510 addresses, 10.1.2.1 until 10.1.3.254. And the broadcast address is 10.1.3.255. And for the third faculty is 420 hosts. So we also use to the power of 9 bits borrowed, and the network address is 10.1.4.0, and the IP address range from 10.1.4.1 until 10.1.5.254, and the broadcast address is 10.1.5.255. FKE with 400 hosts. The bits borrowed is also 9. The network address is And the network address is 10.1.6.0. IP address range is 10.1.6.1 until 10.1.7.254. And the broadcast address is 10.1.7.255. And the fifth one is FKM with 370 hosts. The bit tomorrow is 9. Network address is 10.1.8.0. The IP address range is from 10.1.8.1 until 10.1.6.254. And the broadcast address is 10.1.9.255. Next, FKP with 300 hosts. And FKP also use Bitsboro 9. The network address is 10.1.10.0. IP address range is 10.1.10.1 until 10.1.11.254. And the broadcast address is 10.1.11.255. And for the postgraduate center, 200 hosts. The Bitsboro is 8 because we only need 200. So the 8 Bitsboro 8 provide 259 hosts. The network address is 10.1.12.0 and the IP address range from 10.1.12.1 until 10.1.12.254 and the broadcast address is 10.1.12.255. Next is library with 100 hosts and the Bitsboro is 7. 7 provides 128 hosts and the network address is 10.1.13.0. IP address range is from 10.1.13.1 until 10.1.13.126 and the broadcast address is 10.1.13.127. Register office with 70 hosts. Bitsboro is 7 also and the network address is 10.1.13.128. IP address range is from 10.1.13.129 until 10.1.13.254 and the broadcast address is 10.1.13.255. And the last one is Sport Center with 50 hosts. The Bitsboro is 8, which provides 64 hosts. And the network address is 10.1.15.0. The IP address range is 10.1.14.1 until 10.1.14.62. And the broadcast address is 10.1.14.63. And that's all for the calculation of subnetting.
Network diagram software that used in the project is Draw.io. Draw.io is a popular network diagram software that allows users to create professional-looking diagrams, including network diagrams, flowcharts, origin charts, and more. It is a web-based application that can be accessed through a web browser or used as a standalone desktop application. Furthermore, Draw.io provides a user-friendly interface with a wide range of shapes, icons, and connectors to create network diagram. It offers a drag-and-drop functionality that makes it easy to add and arrange elements on the canvas. This software also supports real-time collaboration, allowing multiple users to work on the same diagram simultaneously. So the next video, we are going to show you how you use Draw.io to design the network diagram.